All right, good morning. This is Dr. Henry, and today what we're going to be trying to do is learn how to write names and formulas for covalent compounds. And you can see I'm kind of gotten fancy. I've got my face in the video today. We'll see if that helps. I don't know. It may just be a distraction because of my uncommon beauty. Right above me, right above me. Wait, hold on. It works the opposite. You can see my faithful, I can't point to him, but there's the lab safety dog. All right, so for covalent compounds, for naming, it's based upon Greek prefixes. So we have gone from Roman numerals, now we're going to Greek prefixes, so we're just traveling around the Mediterranean. So you need to remember these Greek prefixes. Basically, you need to know 1 to 10. So 1 is mono, and remember if this, I think you learned from the POGO yesterday, if the subscript is 1 for the first element, it's not used. So this is mostly used just for the second element in the name, and we'll see some examples of that. 2 is di, 3 is tri, right? Hopefully none of you are writing tricycles anymore. 4 is tetra, 5 is penta, right? Like the pentagon has 5 sides, 1, 2, 3. This is going to be embarrassing if I didn't do this right. 5, look at that. And then I think it has a little thing in the middle. 6 is hexa, 7 is hepta, 8 is octa. Like remember we talked about the octet rule. Octa means 8. Nona is 9, right? Kind of like when you were a little kid, you used to call your grandmother, "Oh, Nona, can I have some more cookies?" And 10 is decade. Sorry, hopefully your grandmother, that's an angry grandmother. 10 is decade, like a decade has 10 years. So these Greek prefixes you need to know. Next slide. All right. So first what we're going to go over is we're going to go over how to name covalent compounds. So what we are doing is we're just doing binary covalent compounds. So they're just going to have two, I was going to write 2 elements, but they're just going to have 2 nonmetals in them. So the first element, when you're naming, it's going to get a Greek prefix for the subscript plus the name of the element, just a regular name. The second element in the formula, it's going to get a Greek prefix. You're going to take the stem of the element name, like, I don't know, down here, we'll see, like oxygen becomes ox plus an IDE ending. And once again, mono's generally omitted except for the second element. So let's look at this example. So the 2, what does 2 mean? Well, 2 means we're going to use a prefix of di. P is our first element, so it just gets its regular name of phosphorus. So diphosphorus. 5 means penta, and then I'm going to do this in 1 second. So O is oxygen, that becomes oxide. Now, one thing you should have learned in the POGO that we did yesterday, when you put penta with oxide, we kind of drop the A, so we don't say pentaoxide, it's diphosphorus pentoxide. All right, let's look at this example. So here we have sulfur. It's understood it's got a subscript of 1. We don't say monosulfur, we just go with sulfur. We have a 6. 6 is hexa, and then F is fluorine, which becomes fluoride. Sorry, I'm running out of space, but hopefully you can spell fluoride. Now, one thing about fluoride, what I'm seeing a lot is a lot of you are spelling it like it's flour. It's not flour-eyed. It's not like this. It's not like you've taken some wheat and ground it up into flour and you made it into an element. It's fluoride. The U becomes before the O. This is wrong. So be careful on that. All right? All right, we're going to skip this one. We did that on the other page. All right, why don't you pause this for a second? Why don't you try the first 3 in this list, and then if you want to do the rest of them later, you can show them to me in class and I can check them. So pause. Oops, I'm going to move this way. I'm pausing. Now, all right, so we're back. Live action. So, S is sulfur. There's only one, so we don't say monosulfur. 3 is tri. And then O is oxide. So sulfur trioxide. Next, silicon. Only one. Excuse me. So we don't use a prefix. And then bromine has a prefix of 4. That's tetra. And bromine becomes bromide. Next, oh look, this is one of the rare compounds that a noble gas can form. We have Xe, which is xenon, and then we have 6, which is hexa, and once again, fluorine becomes fluoride. Now, I just want to skip to this one because it looks like, oh, the first element only has 1, but that's not true all the time. Like, let's look at this one. So we have 2 chlorines, so this would be dichlorine. 7 is hepta. And oxygen becomes oxide. So dichlorine heptaoxide. So that's how you go from the formula to the name. All right, now we're going to learn how to go from the name. Here's the name, tetraphosphorus hexasulfide. I think that's on the lunch menu today. And also, sorry, what happened to my picture? I disappeared. Oh well, I'm here making funny gestures and no one can see me. So tetraphosphorus hexasulfide. So, 2 elements. So we have phosphorus, so we write a P. Tetra means it has a subscript of 4. Hexasulfide. So sulfide is S. Hexa means we have 6. So this hexa tells us the subscript is 6. Sulfide, oops, I missed the point there. Sulfide points towards the sulfur. Phosphorus tells us it's P. Tetra means we have 4. So that's where everything comes from. Let's look at 2 more examples. 3 more. 1, 2, 3. Sorry, I can't count. So nitrogen, trichloride. So tri means 3, chloride is Cl, Cl3. All right, one other thing while we're doing this is Cl. This is chlorine. Some people think I mean this, right? It's not carbon and iodine. So, sorry, breakfast arrived. I had to let him in. So this is not carbon and iodine. This is chlorine. Iodine will always be a capital I. Try to make sure all my capital I's look like this. This is an L. So be careful about that. All right, dibromine. Hepta is 7. Oxide is O. So we got Br2O7. Dinitrogen, pentasulfide, like this. So we got N2S5. So that's basically how you write names and formulas for ionic compounds. If you need help, come before or after school. See me in class. Good day.